what is, well, one of the cardinal commandments in math is you shall not do what one thing?
Divide by 0.
Okay, I'm going to tell you today you can. Okay? All right. So, okay, we're living a little dangerously here. Maybe some little heresy or something. Okay? When you divide by 0, you will get infinity. Okay? When you divide by 0, you get infinity. When you divide by something small, the result is something very large. The converse is also true. When you divide by infinity, you will get 0. Okay? All right, so we just have to release our minds here a little bit, open it up to be able to kind of work with something that you have been coached and conditioned your whole life to think, I can't do that. All right, so let me show you a couple examples before we get into actually doing some limits. All right, so just quickly, 7 divided by 0. What is it?
Infinity.
It is infinity. Okay, how about negative 5 divided by 0? What is it? It is not. It is negative infinity. All right, there are different forms of infinity. Okay, infinity could be considered positive. It could be considered negative. Okay, if you think about the airplanes playing chicken, one is flying, they're each flying off in different directions. They're types of infinity, but they have different signs. They have different natures. Yeah, Holiday.
What would 0 divided by 0?
Ooh, that is such a good question. All right, that is something called an indeterminate form, which is part of chapter 9, which we are actually going to do. We're going to jump ahead and do that, but not until we got to finish up chapter 3 first. So yeah, it's called indeterminate. So is infinity divided by infinity. All right, so you know, it really is unfortunate. Your whole life you've been told you can't divide by 0, then you get to calculus and you realize you can. Your whole life you've been told that anything divided by itself is 1, except not 0 divided by 0 and not infinity divided by infinity. You've also been told your whole life that anything multiplied by 0 will be 0 multiplied by anything is still 0, except 0 times infinity, and that's not 0 either. Okay, but that's a lesson for another day. We'll get there. Okay. All right, so conversely, if you have 7 divided by infinity, what will that be? 0. But just like you had to specify positive or negative for infinity, I need you to specify a positive or negative for 0 as well. So these are both 2 positive numbers, and so I will end up with a 0 positive, yeah.
So could you say negative 5 divided by 0 negative would be infinity positive?
Yes. Yes. Okay. All right, so negative 5 divided by infinity, okay, that would be 0 negative. Okay, so your question, I think of what I'm hearing you right, if I have negative 5 divided by negative infinity.
Then positive 0?
Correct. Okay, good. Good. All right, so just so we're thinking about that. So what does that mean? Okay, well, when you have positive infinity, your asymptote is shooting up. When you have negative infinity, your asymptote is shooting down. Those are pretty self-explanatory. But what about 0 plus and 0 minus? Okay, those are horizontal asymptotes, and that has to do with whether in a horizontal asymptote, let's think of an easy one, like across the x-axis. That means you're coming down towards the x-axis and you're hovering above the x-axis. You're plus. Okay, you're always just barely above the x-axis. So that might be an example like of a exponential. right? An exponential graph would come down here, and but it always stays 0 plus. Okay, it approaches 0, but it approaches it from the top. It approaches it from numbers that are above. It's coming down towards it. So that would be an example of 0 plus. Okay, a 0 minus might be the reverse, where you also have an exponential, but it's coming this way, and it's coming up towards 0, but it's always going to stay on the underside, on the negative side, and so that would be an example of 0 minus. That could be for any horizontal asymptote. If your horizontal asymptote was 5, you'd have a 5 plus and a 5 minus. Are you on the top side of 5 or on the bottom side of 5? That's what that means. Okay, so let's do some actual examples as it talks about limits. All right, when x approaches infinity, any kind of infinity, okay, it could be plus or minus. All right, so that's the limit. All right, so when x approaches infinity in a limit, your algebraic strategy is going to be the same. When you see that kind of a limit, the algebraic strategy is to divide by the highest power of x that's in the problem. Okay, so when x approaches infinity, either plus or minus in a limit, the algebraic strategy is to divide by x to the n, where n is the highest power. All right, that's what to do. Let me show you. Sometimes it makes more sense when you're actually like working it out in a problem. So if we're going to take, say, a limit as x approaches negative infinity, parentheses, of the problem 5x plus 1 over x, and we want to evaluate that. You don't just plug infinity in. Okay, well, why not? Well, what would happen if you did plug infinity in? If we did, we'd get negative 5 times infinity, because negative infinity times would be negative 5 times infinity, plus 1, all over negative infinity. Well, what's negative 5 times infinity? Negative infinity. It's 5 times bigger than infinity is, which is still infinity. And if you add 1 to that, what do you get? You're still infinity. You didn't do a dent. So, but it's a negative number. It would be negative infinity over negative infinity. And this is a case where just because something is over itself, it's not equal to 1. This is called, the definition of this is called an indeterminate form. And you need to know a little bit more calculus to know what to do with that. So that is not the right approach here. Okay, so we are going to eliminate that as being an option. Our algebraic strategy is to divide by the highest power of x, which in this case is what power of x? Just x to the first. Okay, so our algebraic strategy, and as long as we're doing algebra, we keep our limit notation going. So it would be 5x divided by the highest power of x, 1 divided by the highest power of x, and x divided by the highest power of x. We just divided everything by x. Why is that legal? Does it feel wrong? Why is it legal? Why am I allowed to just do that? If I divide everything on the top by something and everything on the bottom by that same something, yes ma'am?
Did you just multiply by x over x?
I did. And x over x is 1. Okay, that's the time that something over itself is 1. I just multiplied by the same thing on the top and the bottom. Okay, sometimes that feels like it's math magic, right? Okay, but it's legitimate. Okay, it's real math. I am multiplying by the same number or variable on the top and the bottom.
It kind of doesn't look like it because you took that bottom one and moved it to the top.
I did.
Top and moved it to
Okay,
the bottom.
because division and multiplication are the same thing.
Yeah.
Okay, dividing by something is just the same as multiplying by the reciprocal. Okay, so I have done something legal. Okay, it's one of those things. All right, now I'm going to reduce, simplify. So I'll have the limit as x approaches 1 over infinity in parentheses, I now have, okay, what's 5 x over x? 5 plus 1 over x over, my denominator is now 1. Because anything over itself is 1 as long as it's not 0 or infinity. Now we can plug infinity in. Ooh, I lost a negative. It's not just x approaching infinity, x approaching negative infinity. All right, now I can plug that in. And when I replace the variable for the value, I can drop the limit notation, and I'll have 5 plus 1 over negative infinity. Well, how much is 1 over negative infinity? We just talked about anytime you divide by infinity, what do you get? Some kind of 0. What kind of 0 in particular? Okay, so this is 5 plus something very small, a negative number. What does that do to the 5?
Oh, it's 5.
5 minus. Okay, 5 plus 0 minus, which is a negative number, means that you're a little bit smaller than 5. That means that you would be approaching this horizontal asymptote from the underside of 5. You're going to come up towards it from the bottom and be leveling off at the number 5, but doing it from underneath. That's what that means graphically. Let's try another one of those. Okay, the limit as x approaches, let's do positive infinity this time. Oh, it's hard for me to, there, okay. All right, parentheses, 2x to the second minus x plus 3 over the fraction, or the denominator, 3x squared plus 5. Again, this is one of those squirrel moments. You're not supposed to get sucked in and distracted and think, oh, I'm just going to plug in infinity. Because if you do, you're just going to end up with infinity over infinity, which is that no man's land of an indeterminate form. Your algebra, you got to be honed into that algebraic strategy. Divide through by the highest power of whatever x is in this equation. All right, so x approaching positive infinity. And I'm going to divide through, this time, by what term of x? X squared is the highest power. What if you've got different powers in the top and the bottom? Just pick the highest one. Whatever the highest one is, that's what you divide by. All right, so 2x squared divided by x squared minus x over x squared plus 3 over x squared all over 3 over x squared plus 5 over x squared. This seems a little bit tedious, but this is a proof. If you're writing a free response answer, you've got to show each step. If this is multiple choice or true false, you don't have to. But on a free response question. Okay, now we want to reduce. So when I reduce 2x squared over x squared, I get 2 minus x over x squared is 1 over x. 3 over x squared doesn't change. My denominator also has a 3 over x squared. Nope. That was 3x squared over x squared. So let's see. Fix this. That's 3 plus 5 over x squared. Okay, after I've done my algebra, I can replace the variable with the value. So as I replace the variable with a value, I can drop the limit notation, and I will have 2 minus 1 over infinity plus 3 over infinity squared over 3 plus 5 over infinity squared. All right, 2 minus 1 over infinity is what? I've got two kinds of zeros here. Okay, so I know both of them are 0. Okay, 1 minus, or the first is a 0 plus. The second one is also a 0 plus. Are those 0 pluses equal to each other? Okay, are those 0 pluses equal to each other? All right, we'll look at the denominators. One denominator was infinity. The other denominator was infinity squared. Based on which denominator is bigger, which of those two 0 pluses is bigger? The one with the smaller denominator or the one with the bigger denominator? Something with a bigger denominator is a smaller form of 0. Right? I mean, compare 1 over 9 to 1 over 81. Right? That'd be like thinking of 1 over something and 1 over something squared. 1 over 9 and 1 over 81. Which one's bigger? The 1 over 9. Okay, the 1 over 9 is bigger. So this one is bigger. So what does that do to the 2? If you subtract something, that pulls you down less than 2. And then you're adding something else. Is it enough to get you back on the other side of 2 yet? Okay, it's not enough. And so this is still a 2 minus. As I subtracted something which made it less than 2, even though I'm adding something back on, I'm not adding enough to change to get to launch me back over. All right, how about the denominator? 3 plus what? What kind of 0 is that? 0 plus. All right, so what kind of 3 is that?
3 plus.
Okay. So I have 2 minus over 3 plus. Is that a positive number or a negative number? Think before you speak. Okay? Is 2 minus over 3 plus a positive number or a negative number? Okay? Is 2 minus a positive number?
Yeah.
It's just, it doesn't mean it's negative. What does it mean? It's smaller than 2. It doesn't mean it's negative. It means it's smaller than 2. All right? And then 3 is a little bit bigger than 3, but that's still an overall positive number. Okay? Still an overall positive number. All right, any questions about the whole x approaching infinity strategy for what you've seen so far? Okay. All right. Then let's talk about the other option. All right, vertical asymptotes. Oh, by the way, these 2 examples I just did, I'm going to shrink it down a minute. Those are horizontal asymptotes. You're always going to get a horizontal asymptote when the x is approaching some kind of infinity. Okay, you're always going to have an end behavior. Sometimes they call them end behavior asymptotes. They want to know what's happening at the end. Okay, when you get to the end of the life of this function, what's going on. So in part A, the end of the life of that function will be that it will be approaching 5 from the underside. Okay, in part B, the end behavior of that function, the end of that life of that function is that it will be approaching 2/3 also from the underside of 2/3. Okay, vertical asymptotes. Vertical asymptotes, when do they occur? How do you know you're going to have one? Think of like a hyperbola. That's got a vertical asymptote. Like, how do you know you're going to have one?
You have your variable in the denominator, and it's able to hit 0 at some point.
All right. Vertical asymptotes occur when the denominator is going to be 0. So here's the opposite, right? The first 2 were when the x was approaching infinity. Here, the denominator is approaching 0. That's when you're going to create a vertical asymptote. All right, so here's an example under this category. F of x equals x plus 3 over x plus x minus 2. Clearly, that is going to have a vertical asymptote. Where will the vertical asymptote occur?
2.
At 2. Your job is to figure out Who's playing chicken? Okay, as it's approaching 2 from the right side and the left, or the left side, your spectator, and the right side, who's going what way? Okay, are you playing chicken like this? Are you playing chicken this way? Or are you both going that way? Like, how is this going as both sides are approaching? And so your job then is to set up 2 separate limits and to investigate what's going to happen when I approach 2 from the left, parentheses of x plus 3 over x minus 2. And to investigate what's happening 2 to the right of x plus 3 parentheses x minus 2. I do not need to divide through by the highest power this time because I'm not plugging in infinity. The only time you need to divide by the highest power is when you're plugging in infinity. This time, I'm just going to plug in 2 minus and 2 plus. All right, so I'm going to plug in 2 minus plus 3 over 2 minus minus 2. 2 minus plus 3 gets me close to 5. On which side of 5 will I end up? Okay, 5 minus, a little bit smaller than 5. 2 minus minus 0 gets me close to 0. Which side of 0 will I end up on? Something smaller than 2, and I'm taking away a full 2. So where will I end up? 0 minus. Okay, now anything divided by 0 is going to be infinity, but I just need to know what kind of infinity. Okay. All right. Is it positive or is it negative? All right. Are these 2 negative numbers?
No.
No. We've got 1 positive number on the top and a negative number on the bottom. Yeah, 0 minus is a negative number. 5 minus is not a negative number. 0 minus is. Okay, 0 minus, remember? 0 minus is a negative number. So we have a positive number divided by a negative number, which means the person who's playing chicken, approaching from the left-hand side, is going to dive bomb down to negative infinity. Let's plug in 2 plus. 2 plus plus 3 over 2 plus minus 2. Everybody likes to plug in pluses. They just feel easier to me. Okay, so 2 plus plus 3 gets me close to 5. On what side of 5 will I end up on?
1.
Okay, and then 2 plus minus 2 gets me close to 0. On which side of 0 will I end up on? Okay, and that is clearly 2 positive numbers. So that will be positive infinity. So that person's heading off on their asymptote to positive infinity. Yeah.
So the only number that's made positive or negative by those pluses and minuses
Is 0, correct. Okay, every other number, like negative 5 minus, sometimes we look at that and we see 2 minuses and we think, oh, that's a positive number. But negative 5 minus is still a negative number. Okay, last example, and we're done for today. I'm going to give you something you already know, but we're going to prove it. G of x equals tan x. You already know that tan x has lots of vertical asymptotes over and over and over again. You already know that. You learned that. But we're going to prove it using limits. So pick me one of tangent's asymptotes. And you could prove it for any of them. Where will tangent have an asymptote? Not pi, but pi over 2. Okay, pi over 2. And so all you need to do is prove it. You could pick any of tangent's many asymptotes. Okay, we'll just pick pi over 2. So we're going to take the limit approaching pi over 2, and we're going to look at it from the left. And we're going to take the limit approaching pi over 2, and we're going to do it from the right. Now, we already are familiar with this graph. We could answer it without, but this is the proof. Oops. Okay. To prove it, you need to have a denominator. How can I bring a denominator into this question?
Sine over cosine.
Okay, good. So the limit approaching pi over 2 from the left, I will now be doing for sine of x over cosine of x. Okay, so we need to evaluate what is sine of pi halves approaching from the left side, and what is cosine of pi halves approaching from the left side. And so we need to think about, you could either do that on a unit circle if you want to approach that way, or you can do it by how you know the graphs to be. Okay, for sine, I know the sine graph looks like this. And I know where pi halves is on that sine graph. I know that pi halves is right here. If I'm approaching that point from the left-hand side, I'm approaching this little maximum peak. So I'm getting close to 1, but what side of 1 am I on? Okay, am I more than 1 or less than 1? Okay, I'm at 1 minus. So I know this value is going to be 1 minus. For cosine, okay, I know cosine looks like this, and pi halves is right here. So as I approach that, I'm approaching 0, but what side of 0 am I approaching? 0 plus. I'm above the x-axis, and so this would be 0 plus. What kind of infinity is that? Good job. You didn't get distracted by the negative sign. Okay, that negative sign doesn't mean a negative number, it means a left number, so this is positive infinity. In a similar way, we can do the same thing to the other one. So we would create ourselves a denominator, approaching pi halves from the right, and I'll be doing sine of x over cos of x. And so I'll want to know, well, what is sine of x when you're on the right side of pi halves, and what is cosine when you're on the right side of pi halves? So you could look at the graphs again. When you're just barely on the right side of pi halves, this sine value is starting to decrease, starting to go back down. So I'm close to 1, but what side of 1 am I on? Okay, I'm still on the lower side, right? Because this is 1, and these 2 points right here are both 1 minus, and that is also 1 minus, because I'm lower than 1. And so the value of that is also 1 minus. Cosine, okay, looking at the graph right there, when I'm beyond pi halves, I'm pi halves plus, I've crossed the x-axis, and I've now crossed into a different quadrant. And so now I'm below. I'm 0 minus. Okay? But don't get suckered in to think that those 2 minuses make a plus. They don't. Okay, this is still a positive number. This is the only one that's a negative number. So this kind of infinity is negative infinity, which should confirm what you know about tangent in the first place. You know that a tangent graph is shaped like this with repeated periods, and we happened to pick the asymptote that came down at pi halves. And we can see then that on the left side, as you get near to that asymptote, that's the side of the tangent that heads up to infinity. And on the right side, that's the side that plunges to negative infinity. So you have 2 things to think about, and it's all going to depend on what the limit is approaching. If the limit is approaching infinity, that's your strategy of dividing by the highest power of x. If your limit is approaching a physical number, then you check both sides of it and then see what kind of infinity you end up with at the end. So do you see how infinity plays a role here? Either infinity is the thing that x is approaching, and then you're going to get a number, or you're approaching a number and you're going to get a kind of infinity. It's the reverse, and one of them is a horizontal asymptote and the other is a vertical asymptote.